We want to look at this question related to the goods market, where we're told that the goods market of a closed economy is characterized by the following equations. We're given our consumption function as a linear function of disposable income. We're given our investment, government spending, and taxes as exogenously given. We're asked to, in the first part, to find the equilibrium level of output, and in the second part, we want to graph our goods market diagram. So, in the first part, if we do it, we know the equilibrium output is given by y is equal to z, where y represents our output or income, and z represents our demand for goods, where we know z is c plus I plus g plus nx. So the idea is that we first need the demand function z. In this particular case, we can see t is equal to t bar. We're given, so we have lump sum taxes which don't depend upon income. We're given c is equal to c naught plus c1 yd, which is y minus t, right? So we're given this. This is essentially just disposable income, which is income minus taxes. And then if I substitute the taxes that were given in this case, which are lump sum, this becomes y minus t bar. And then now if we just combine the like terms, so we combine the terms that don't depend upon y together, which is like c naught minus c1 t bar plus c1y. So this is a simplified form of a consumption function. So this is our consumption function, and then we're given कि I is equal to I bar exogenously given, and we have G is equal to G bar also exogenously given, and we have net exports equal to 0 because we're looking at a closed economy. So we first need the demand function z, right? So what we can do is, so the demand function z is just equal to c, which we know is equal to c naught minus c1 t bar plus c1y plus it's equal to I, which is equal to I bar plus G, which is equal to G bar, right? So we've written our total demand for goods C as C plus I plus G. Now, if we again just simplify this a bit and combine terms which don't depend upon Y and those that do depend upon Y, this becomes C naught minus C1 T bar plus I bar plus G bar plus C1Y, right? And this is what we call autonomous spending. So this is part of demand that does not depend upon Y. In other words, demand when Y is 0. Or in other words, demand when Y is equal to 0. So now that we have a demand function Z, we can find equilibrium output easily. So now I'm just going to clear all of this up. Right, so once I found the demand function Z, thus equilibrium Y is given as y is equal to z. Now I can just plug in the demand function that we found, c naught minus c1 t bar plus I bar plus g bar plus c1y. Now we can combine the y terms on one side, 1 minus c1, y is equal to c naught minus c1 t bar plus I bar plus g bar. And then from here, equilibrium y is 1 minus c1 into c naught minus c1 t bar plus I bar plus G bar, and this way we found equilibrium output. The second part now asks us that we want to graph the demand function as a function of income, and you want to label the equilibrium value y from part A in a graph. So graphically, we know the goods market equilibrium. Graphically, we know, so for part B, we know goods market equilibrium is given at the intersection of 45-degree line and demand schedule Z. So there are two main components, right? Because we do want to label the equilibrium level of y on our graph. You know, graphically, the goods market equilibrium is given at the point of intersection of the 45-degree line and the demand schedule. If you look at the 45-degree line, we know this is an upward sloping line with slope is equal to 1 that goes through origin. Now let's look at our demand schedule. Note the demand function Z. Note the demand function Z is a linear function of y in this case, right? When we found it was a linear function of y in this case, right? Recall what it was. Let me just quickly write it down over here. So we found Z is equal to C naught minus C1 T bar plus I bar plus G bar plus C1y. So we can see it's a linear function of y in this case. It's a function of y just to the power 1. You don't have y in log form. You don't have any trigonometric function of y. You don't have y being multiplied with itself. So z is just a linear function of y in this case. So its graph will be a straight line. So its graph will be a straight line in the yz YZ plane, right? Sorry. So basically, like we're saying, in this particular case, demand is just a linear function of y because it's just a power of y to the power 1. So its graph is going to be a straight line in the YZ space. So let's recall general equation of straight line. What is the general equation of straight line? We know the graph of z against y is a straight line. So let's just recall the general equation of straight line and compare it with our equation of straight line to find the slope and vertical intercept, right? So we know that z is equal to c1y plus c naught minus c1 t bar plus I bar plus g bar. So if we compare this, then z is the variable we know that's going to go on the y-axis. Y is the variable that's going to go on the x-axis, right? And from here we can see m represents slope. So c1 is the slope in this case, right? So this is the slope. And we know this is the vertical intercept in this case, right? Right, so if we just now look more deeper into this, so we know we have z is equal to c1y plus c naught minus c1 t bar plus I bar plus g bar. We know basically this is the slope. So we know the slope is c1. Now a couple of things to note over here is the slope is between 0 and 1. As c1 is between 0 and 1, it's the MPC it's given to us, it's between 0 and 1. So now what does this imply? The slope is greater than 0. So this means upward sloping. So the demand function that we plot against y is upward sloping. The fact that the slope is less than 1 means so the demand schedule is flatter than 45-degree line which has the slope 1. Right, so there are two things about the slope we know. So when we're plotting the demand function against y, it's going to be upward sloping because the slope is greater than 0. And it's going to be flatter than the 45-degree line as the 45-degree line has a slope 1 and the slope of this, which is c1, is less than 1. And this we know is the autonomous bending. This is our vertical intercept, which represents autonomous bending, right? Part of demand that does not depend upon output or income. In other words, demand when output or income is 0. So now if we were to actually graph this finally, So we know how we're going to graph this. Right, so now if you were to graph this, number one, we'll make the 45-degree line. Oh, sorry. So we'll first make the 45-degree line. Let's just right. So on the vertical axis we had demand for goods C. On the horizontal axis we have output or income Y. So we made a 45-degree line. Like we said, this is an upward sloping line, right? And the slope of this is 1. So we know this is an upward sloping line passing through the origin which has slope 1. Now let's make a demand function Z. So when we plot our demand function Z, we know it's going to be upward sloping and flatter than the 45-degree line, right? We've already seen its slope is between 0 and 1. Greater than 0 means it's upward sloping, right? And so this is Z is equal to C plus I plus G equal to C1y plus C0 minus C1t bar plus I bar. We know the greater than 0 part means that the slope is between 0 and 1. The greater than 0 part means it's upward sloping. The less than 1 part means it's flatter than 45-degree line, which has a slope 1, right? And then this we know is the autonomous bending component, which is C0 minus C1 t bar plus I bar plus G bar, right? So this is autonomous bending its vertical intercept. And we know goods market equilibrium occurs at the intersection. So this is the goods market equilibrium level of output Y star, equilibrium Y. Right, so we know, like we said, goods market equilibrium graphically occurs at the point of intersection. Goods market equilibrium occurs with the 45-degree line intersects the demand schedule. This is where Z is equal to Y. And because we know in the goods market equilibrium Z is equal to Y, so this means that we can, so this means in goods market equilibrium, the value of y on the horizontal axis, the equilibrium value y is equal to the value z on the vertical axis. So we can also represent the equilibrium level of output on the vertical axis. Because we know in goods market equilibrium, z is equal to y. So this means whatever y is on the horizontal axis, which is y star, is the value z on the vertical axis, which will also be y star, because in goods market equilibrium, they have to be equal. So you can represent the equilibrium output on the vertical axis also like this.